Hello.
Hello. Hi, Tess.
Okay. Okay, guys, so let's begin our office hours. So you can use our chat to post questions. I see there are already some questions. Mhm. The first one is about multiple choice 10 from 2000. Okay, let me open it. Uh-huh. So given function f x cubed minus 3x for negative x's, x5 minus x for positive x's, we should find the number of critical points. Okay, let's do it. So, okay. Mhm. So, first of all, remind me what is a critical point?
A point where the derivative is 0 or doesn't exist?
Right, exactly. So, now let's discuss what is derivative of function f. So let's try to calculate f prime x. So since function f is defined differently for positive and negative x's, we should calculate corresponding derivatives for each of these intervals separately. So for x being smaller than 0, our derivative is 3x squared minus 3. For x's that are positive, our derivative is 5x 4 minus 1. Right? Now, at 0 point, we should calculate derivative separately based on the definition. And then, first of all, understand whether derivative of 0 exists or not. If derivative doesn't exist, that point would be a critical point. And beside that, we will find zeros of derivative of our function. Okay, so maybe we can begin with calculating zeros of f prime. So f prime equals to 0, which means either 3x squared minus 3 equals to 0. And this part means that x squared equals to 1. So x is plus minus 1. But since we are looking for, at this point, negative x's, we have x1 equals to minus 1, a critical point. In the same way, we will discuss the second component of the derivative f prime x is 5x 4 minus 1 equals to 0. Here, x4 equals to 1 over 5. And we have, for positive x's, if we assume x to be positive, 4 or the root of 1 divided by 5 is our second critical point so far. And now let's understand what's going on at point 0. To do that, we will consider the definition of derivative of function at 0. So their function is differentiable at 0 if the following limit exists. Limit x goes to 0. of function fx minus value of our function at 0. 0 is defined here. So f0 is 0 to the power 5 minus 0, so it's 0 divided by x. We should consider sided limits in this case. Limit x tends to 0 from the left side, fx over x is limit x tends to 0 from the left side. So instead of f of x, we can plug x cubed minus 3x divided by x. And limit here is what?
-3.
-3, exactly, because x cubed over x gives just x squared minus 3. X squared minus 3 tends to -3. So, okay. And also we should consider limit from the right side. Limit x tends to 0 from the right side. Our function x5 minus x divided by x. And what is the limit of this one?
-1.
It's -1. Thank you. -1 is different from -3. So our immediate conclusion is that, so since this is different from -3, we can say derivative of our function at 0 doesn't exist. Hence, x3 equals to 0 also is a critical point. So far, we found 3 critical points. If we go back to our exercise, here we have 3 as the correct answer. Right? Okay, let's move forward. Yeah, since we are working with a version from 2016, we have other questions from that year, 3rd, 5th, and 10. Okay. 3.
Can I ask you something?
Yeah, please.
So where we calculated the limits here, what if the limit existed and it was 0 from both sides? Would it be a critical point as well?
Yes, it will be a critical point in that case because derivative exists and equals to 0. If sided limits exist, or limit exists, which means both limit from right and left gives the same number, but not 0. In that case, 0 point is not a critical point.
Thank you.
So either sided limits are different, so we have a critical point, and also if sided limits are equal, still, if it is 0, it's a critical point. Okay, now Hertovanek. So multiple choice with 10, we did it. Applying definition with big O, small o. Okay, let's continue our examples from previous years. And if we will have something related to big O, small o, we will discuss about definition, how we can tackle that exercise by definition, or we will modify in a way that definition will be needed to be applied. 2021 multiple choice 5. Okay. Yeah. So here we are given a function f. Yeah, this is a tricky one. And here in this exercise, one important condition is not really clearly mentioned. F prime at 1 or at -1. Let me see. At -1. So exist or not. So this condition will be critically important for this exercise. Let's see. So given function f, which is continuous, and some values are given of our function. At -1, our function is 5. At 1, our function is -3. At 4, the value of f is 2. We know that it's monotonic from -1 to 1. So it links these 2 points. So it is going to be decreasing. From 1 to 4, it's monotonic. So it would be some increasing function. And here, from -4 to -1, we are given function to be concave up. Actually, it says second order derivative is strictly positive, but look, -1 is a right endpoint of our interval, and it's not clearly stated whether derivative of our function -1 exists or not. When we are saying double derivative is positive from -4 to -1, maybe at -1 we are discussing here derivative only from the left side. So this part of this exercise is not very well formulated. So if we are forgetting about being differentiable at -1, we may have this type of situation. At -1 it is not differentiable, but from the left side it is differentiable. So if we have this case, we might have 4 solutions. If we do not, if double derivative being positive from -4 to -1, we are interpreting as at -1 it is 2 times differentiable. So here it should be smooth without any kink points. In that case, it will be something like this, concave up, right? And there is no any 0 in that case. So exactly 2 solutions will be correct answer. But the formulation, once again, here about derivative -1 is not really very well given. So I will hesitate between A and B. It's either, so 4, since we are considering here f double prime being positive from -4 to -1. So we are talking about -1 to be endpoint of our interval where derivative is considered to be just side-edge derivative. In that case, yeah, like in this picture, it's shown 4 solutions may happen. And if we are considering here -1 is a point from -4 to 4 interval where second order derivative positive means function is differentiable, so no kink point should be appear here. In that case, we are going to have exactly 2 solutions. Now we have these 2 options. Is it okay, guys?
But couldn't we draw it smoothly and it went down?
And then
No?
concavity will be changed.
Oh.
Look here, if you are increasing and then joining smoothly even, then concavity here is changing. Before one function can't be concave up, it will become concave down.
Oh, okay.
And second order derivative can't be, in that case, strictly positive.
Thanks.
Okay. So let's move forward. What is our next question? Multiple choice number 5. We did it. 2017, 7 and 8 multiple choice questions. 17, 7 and 8. Okay. So let's. Okay, so 2019, 17. I need to download it. Sorry. No, sorry, this is midterm 1. Midterm 2. Here we go. Okay, so we should find here a constant a for which these two functions f and g will be either continuous. Okay, it's about continuity of these functions. First of all, guys, before discussing given statements, for which value of a, f will be continuous. So to be continuous function, limit from both sides, from left and right, should be equal. So from the right side of our f of x is, the right side is x, so here we have 0. Limit from the left side of our f of x is a. To be continuous function here, a should be equal to 0. What about function g? Limit of this part from, this is the limit from the right side, is what, guys?
2.
Thank you. And from the left side is a. So, and here continuity holds if a equals to 2. For function f, continuity holds when a equals to 0. And now after this calculation, let's find the correct statement. F and g are discontinuous at 0 for every a. Not true, because when a equals to 0, f is not discontinuous. So that's wrong. F, G are continuous at 0 for a equals to 0. No, for a equals to 0, g is not continuous. Wrong.
Sorry, can you say how we got the 2 for gx?
Yes, we have applied useful limit exponential 2x minus 1 divided by 2x, right? We have multiplied and divided by 2. And exponential 2x minus 1 divided by 2x tends to 1. So limit will be 2 from the right side. And from the left side, the limit is a. To have a limit exists if limits from right and left are equal, so a should be 2. F and g are continuous for a equals to 1. No, only g is continuous for that case. So let's drop it here as well. D statement says at least one of f and g is discontinuous at a for every a. Seems to be correct answer. If a is not 0, not 2, both are discontinuous. If a is 0, g is discontinuous, a is 2, f is continuous. So either one will be always discontinuous. So D seems to be correct answer. And E says that at least one of f and g is continuous at 0 for every a. No. When a equals to 725, both f and g will be discontinuous. So it remains just D to be correct answer. Okay.
Can you please repeat why C was wrong?
Yeah, because f is not continuous as a equals to 2. When a equals to 2, f function will be not continuous. Function f is continuous only if a is 0. Because limit from the right side as x tends to 0 is 0. A minus x tends to 0 if a equals to 0.
Okay, thank you.
And the next one, 8. We have two functions, f and g. F has removable discontinuity point. Removable means that limit of function exists, but is different from the value of our function. So limit of f exists as x goes to 1, but this number is different from f1. And g has jump discontinuity. Jump discontinuity means sided limits are different. Gx as x goes to 1 from the left side is different from the limit of g from the right hand side. So we have two different limits for g. For f, both sided limits are equal but different from f1. Now we should find correct statement for f plus g. F plus g, actually look, sided limits for f plus g will be different, because for f, right left gives the same number, but for g we have two different limits from right and left. So f plus g will have jump discontinuity. Do we have such statement? It has jump discontinuity, so this will be correct answer. Sorry. This is the correct answer. Okay. Has removed discontinuity at 1? No, it is not removable. It's jump. Essential discontinuity, of course, no. Continuous, no. Yeah. So removable plus jump gives always jump discontinuity, because sided limits will be different. Okay. Let's move on to the next question.
Can you
2020.
please explain the essential discontinuity?
Essential discontinuity of function means at point 1 function has essential discontinuity if either limit is infinity from right or from left, or limit doesn't exist. So for jump discontinuity, we should have finite sided limits but different values. For essential discontinuity, either one, maybe both, tends to infinity, or limit, sided limit, doesn't exist. So typically we have the infinity case. And of course here it's not essential discontinuity. If you have sided limits, finite numbers plus removable discontinuity, where again sided limits are finite, finite number plus finite number will be finite, not infinity. So essential can't be true here.
Thank you.
Two 2022. Multiple choice number 8. Okay, so given graph of f prime, this is graph of f prime, and we should calculate what inflection points from f prime, how we can understand inflection points. So typically when we have given function f, to find the inflection point, we should have look at f double prime. So here we are given f prime. So we should think of derivative of this graph should change the sign. Derivative change the sign means we are looking for extrema points of this graph. Extrema points. And we have here a maximum point, and here we have a minimum point. So maximum minimum for f prime are inflection points for function f. So we have here just two inflection points. Extremum points for f prime are inflection points for function f. Why so? Because extreme point for f prime means the derivative of f prime changed the sign passing through this point. F prime from increasing became decreasing or vice versa, which means double derivative for f changes the sign. Okay, so we have two. Pay your attention that here, maybe we have a critical point. I don't know. It's not graphically, we can't identify is this a critical point or not, but definitely this point is not an inflection point for f prime. It's not an inflection point for f. Why so? Because f prime is increasing here. So double derivative is positive from -3 to whatever is this point. So concave up is our function f from -3 to this point. Let's assume this is 3. From -3 to 3, our f function is concave up because first order derivative is increasing. Okay?
So it should be both extrema points and change the sign on both sides. So it should increase and then decrease in the derivative to say that it's an inflection point.
Extrema point is a point where function from increasing become decreasing or from decreasing to increasing. This is an extrema point, not critical. We are calling it extrema point. So yes, it should be extrema point to be inflection for function f, which is the case here. We have only two such points.
Sorry, when we have an open interval, can we say that endpoints are critical points?
No, for open interval, endpoint doesn't belong to our domain where we should consider or find local extrema. For open interval, drop endpoints, they are not local extrema points. For sure, they are not critical points. They are not inflection points. For open interval, everything outside from your domain are not something that we should be concerned. Okay. 2017 multiple choice 4 and 6. Okay, 2017.
And can I ask a question?
Please.
If we have a limit to calculate, can we use both useful limits and L'Hopital, like make use of useful limits and then change L'Hopital at some point?
Not only you can, but please do it. Please simplify your calculation. Think about your instructors and TAs who are going to grade. So if it is possible to minimize the number of L'Hopital, the number of, I don't know, derivatives, do it. So if there is a room for simplification of your calculation, do it.
Okay, thank you.
2017, guys, very soon, like in 5 minutes. Am I right? Our connection will be interrupted. You will join back using the same link. 4 and 6. Okay. Function f is continuous on closed bounded interval. 1, 2, 3 is our interval. Which of the following set might be the range of our function? Okay, so this is a typical exercise where we are going to apply extreme value theorem, which says that continuous function is bounded. It has mean, minimum, maximum if domain is closed bounded, which is the case here. And we are going to use IVT, which says if your function at some point is A, at some point another point B, so all values from A to B is achievable by our function. So in that case, we are dropping A because it contradicts to extreme value theorem. It should have maximum, not the case here. We should drop B. Once again, it contradicts to extreme value theorem. It should have maximum, not for this interval. We will eliminate C because it contradicts to IVT. 3.17 should be from this range because 3 and 4 points are achieved by our function. Anything in between also should be from the range. The same way D contradicts to IVT. All numbers from -1 to 1 also is achieved by our function. So it remains none of the above answer. Okay. And also the sixth. Okay. AB open interval is given. We should find how many critical points do we have. So this is a graph of F, not F prime, not antiderivative, not double derivative, just graph of F. We should calculate critical points. So how we can do it? First of all, identify all extrema points. Extrema point is a critical point for sure. Graphically, finding extrema points is easier. 1, 2, here derivative doesn't exist. It's still a critical point. 3 and 4. We have 4 points. Now, what's going on here?
Here also maybe derivative is equal to 0.
The key word here was maybe. Yeah, maybe. And graphically, just justifying that here we have a critical point is very hard. Almost impossible to say. Do we have another critical point here? It's a tough question. Why we are hesitating? Because it's possible to have a critical point. Sorry. It is possible to have a critical point which is not an extrema point. Exactly in the same way as is graph of x cubed. For x cubed, we have that situation where 0 point, but here, even if we zoom in, it will be not clear, like what's going on here. Do we have a critical point or not? So 4 for sure, and not any like clear evidence that we have here another critical point. I'm not sure that we have here. Maybe we do, maybe. Not an extreme point, just critical. I would go with 4, but 5 also could be correct answer. So, okay, let me suggest the solution. If we have this exercise, 4 and 5 will be considered both to be correct answer. Okay. What was the next question? Show work 1 from 2022. Okay, guys. So it's going to be interrupted our meeting. please come back using the same link. You guys, welcome back. Let me share my screen. So we should study the continuity of this function at 0, 1, and 2 points. To do this, we have to consider sided limits. Limit x goes to, let's begin with the continuity at 0. Limit at x tends to 0 of our function f of x is limit x tends to 0 from the left side. For negative x's, our function is defined as sinus x to the power of 11 divided by 5 times x to the power of 11. And simple useful limit is enough here. This part goes to 1, so overall limit is 1/5. Which is different from f0. f0 is 5. So no need to calculate limit of our function from the right side, because directly now we can say 0 point is a discontinuity point. Our goal is just to find discontinuity point. No need to classify them as jump, removable, or essential. So we can just skip the calculation of limit from the right side. It will give no any insight about continuity, because we know already that our function at 0 is discontinuous. So 0 is discontinuity point. Now, limit at 1 from the left side of our function f of x equals to the limit x tends to 1 from the left side. On the left side of f, our function is defined as 5th order root of x squared plus 1 minus 1 divided by x squared. How we can calculate this limit, guys? I have several suggestions. Apply L'Hopital rule 2 times. Apply useful limit first, then L'Hopital. Just apply useful limit. Divide numerator denominator by x squared. Or just plug instead of x1.
We should just plug 1.
Of course, because we do not have here any indeterminate form. Just plug instead of x1. We'll get immediately limit is 5th order root of 2 minus 1 divided by 1. Okay, it's hard to imagine that limit from the right side will be this number. So we can again skip the calculation and say our function is discontinuous. And when we'll grade you, we will skip giving you whole points, because no, we need to do the calculation. Okay, let's do the following. Let's calculate the value of our function at 1. It's 4 minus 3 minus 6, right? So it's minus 5. These two numbers are different, and one is a discontinuity point. And now it's time to check the continuity at 2. And of course, you remember the logic. If we have 3 points, at least one will be continuity point. So again, we can skip the calculation, but you know already that skipping calculation typically impacts your grade. So x tends to 2. From the right side, we have x squared minus 4 divided by x minus 2. Its limit x tends to 2 from the right side of x plus 2, right? X squared minus 4 is x minus 2 times x plus 2. Here is 4. And what is the limit from the left side? From the left side, what was our function? Yeah, we have this polynomial. 4x squared minus 3x minus 6. So it is 4 times 4 minus 3 times 2 minus 6. Okay, 16 minus 6 minus 4 minus 6 gives 4. And also, please guys, also calculate value of our function at 2. It's going to be the same for here is also the value of function, same thing. So conclusion is that f is continuous at x equals to 2, right? So we are done. Multiple choice. Oh, 2015. Guys, could you send midterm from 2015? Otherwise, I will spend some time to seek this midterm exam. If you have it with you, just share and we will solve multiple choice questions. Show work 4.
I shared it to the chat.
Okay, thank you.
Sorry, can you say why we could skip the calculation for when x goes to 2?
Bad joke only. I said most probably it's going to be
Okay.
continuous because previous 2 points are discontinuous points. No.
Okay, got
The
it.
only thing that in this exercise we can skip is the following. When limit from one side is different already from the value of our function, no need to check limit from the other side because our function is not going to be continuous. So where we stopped 2015. Multiple choice 10 and show work 1. Okay. Here we go. Multiple choice number 10. Given a graph of function f, we should understand what could be the graph of f prime. Let me, keep like this our zoom. So the main idea here is let's try to understand differences of these graphs for derivative and then come up with the correct answer. So far, look here, from -2 to 0, all given derivatives almost behave similarly. There's a small difference, but let's do not pay our attention to that part. Very clear difference is this part, okay? For graph A, it oscillates, it changes the concavity here. Near 6 and 7, we have change of concavity, not the case for our function f. If you remember, f prime changed the monotonicity, this implies that function f changed the concavity. So A can't be correct. It remains B, C, and D. Another difference that we can find is this part. After 8, what's happening? For graph of function C in C, derivative after 8 keep increasing. But for function B and D, here somewhere, like at 0.9 something, it seems that we are going to have extremum points. And concavity is changing at 8 point. Not the case for our function f. At 8, we do not have any change of concavity. So we will pick C to be correct answer. Do you have any other suggestion for this exercise, guys? How we can find? The main difference, yeah, between B, C, and D is what happening after 0.8. After 0.8, for B and C function, derivative changed the monotonicity from increasing, they became decreasing. So 8 is an inflection point, but now 8, there's still function concave up. So f prime should be increasing. C is the correct answer.
But here we excluded options A, B, and D, right?
Exactly, yeah.
We don't know if it is the derivative of this function or it's none of above.
Oh, lovely. You are right. To be honest, you are right. Because maybe graph of our function derivative at 3 or at 4 should be not like this, but it should grow a bit higher. But no, check. See, please check. See.
Okay.
But you're
Thank
right.
you.
But if we find like starking differences in A, B, C, should we also check like find other points for C to be sure that it's the correct answer?
Come on, guys, it can't Christian Kelly. Or who knows? Yeah, I understand your point that even though we have eliminated 3 answers, C could be still wrong. Could be, theory it could be, but if we can't find immediate like straightforward difference, then it is the correct answer.
Մի հատ հարցնամ էլի։
Yeah.
Եթե օրինակ համար ֆունկցիայի դոմեյնը մեծ է կամ հավասար 0, այսինքն 0-ից անվերջն ու 0 included։ Առաջի կարգի ածանցալի դոմեյնը 0-ից անվերջն է, 0 not included։ Իսկ երկրորդ կարգի ածանցալում concavity-ին հաշվելուց մենք գտանք օրինակ համար 0-ից 1 ինքը concave up է։ Մենք 0-ն ներառում ենք մեր պատասխանի մեջ, թե չէ։
For concave intervals, endpoints always include to your domain. If it is concave up from 0 to 1 open, then it is concave also from 0 close to 1. At point, concavity is not changing. So always consider closed interval for concavities. And for monotonicity, only if that endpoint belongs to the domain of definition of your function. In your case, 0 was from the domain of definition, so yes, include 0.
Last
So
message.
if zero is in the isn't in our domain of definition, then we should not include it in the concave.
Yes, if some point doesn't belong to domain of definition, that point can't be a part of your monotonicity interval, can't be a part of concave up, concave down intervals. It can't be a critical point. It is not from domain, means it shouldn't be a point where we should claim something about function f.
Thank you.
Իսկ բացով գրելուց ինչն է սխալ ելնում։
Սխալ չէ, կիսատ է լինում։ Մի փոքր կիսատ է լինում, because endpoint sense ասեմ, այդքան մեծ նշանակություն չունի մաթեմատիկորեն, but if we can find larger interval, do it.
Լավ, մերսի։
Okay, prove this inequality. Do you have suggestions how we can prove this inequality?
Can I say how I proved it
Please.
and say if it's correct or not? First, I divided both parts by x. Since x is positive, then we can do it. Then I said our function is ln 1 plus x divided by x. Then I find the derivative of the fx. It is x over 1 plus x. In the over 1 plus x minus ln 1 plus x.
Okay, so the derivative of this function, we have log it 1 plus, x divided by 1 plus x minus ln 1 plus x divided by
x squared.
Yeah.
Then I found that the range of x divided by 1 plus x is from 0 to 1. And the range of ln 1 plus x is from 1 to infinity. So ln 1 plus x is always greater than x divided by 1 plus x. So this is always negative. And then I found the limit as x goes to 0 for our function, and it's 1. So since 0 is not in the domain, then it's always, and it's decreasing, then it's always smaller than 1.
Yeah, everything is fine, except maybe without dividing by x, maybe just considering g of x to be, for example, x minus log 1 plus x. And our goal is to prove that this function is positive. We can apply the same technique as you have done for function f, but now taking derivative for this function is a bit easier. G prime x is 1 minus 1 over 1 plus x. If you bring this into common denominator, 1 plus x, and we have x here. X divided by 1 plus x, which is strictly positive since x is positive. So g is increasing. And pay your attention that function g is well defined at 0. No need to calculate limit here. G0 is well defined. So G0 is just 0.
But can we like find the value of g at 0 if we don't have it in the domain?
G of x. So we have introduced g of x. This is g of x. And we have, forget about the exercise that we are solving. We have this function x minus log at 1 plus x, and we are starting function x, gx on domain from -1 to plus infinity, where it is defined. The domain of definition of g is from -1 to plus infinity. And here function is from 0 to plus infinity, it is increasing. Gx is increasing. Hence, gx will be strictly positive, xs strictly positive. What we wanted to get.
Իսկ շովորքում այսքան լրիվ հերիքա պետք չի գրել օրինակ համար g0 plus epsilon-ը մեծար 0-ից
Չէ. G0 plus epsilon is G0 in this case is completely enough.
Okay, thank you.
Show work for from 2022. So we are given some function and we should find extrema points and monotonicity intervals. Okay.
Professor, can I ask something related to the previous exercise? We had similar type of the exercise in the homework, and but it was with poker havasarer, meծ հավասար չեմ հիշում. And in that case, we used tangent line to prove the same thing. Will it work here or not?
Even in your homework, that was not critically important to prove that exercise based on tangent line, etc. Here, the exercise was simple than you are mentioning. Just concavity. Okay. So you have used concavity, if I understood correctly.
I used the fact that the function will be always lower or
lower than tangent line means it's concave down.
Yes.
Of course, you can using concavity to get some inequalities based on tangent line, etc. No need here. That was even like taking derivative was enough to have increasing function. But yes, of course, if you are getting that type of inequalities based on concavity, that concave down also is equivalent that tangent line is greater than curve, of course, please do it. But I hesitate that we are going to have exercise where the only way to solve is like that. Even in your homework, that was not like must. We can avoid that approach and find inequality otherwise.
Okay, thank you.
What is f prime? We have product, so let's apply product rule. Derivative of x to the power 2/3 gives 2/3 times x to the power of 1/3 times e to the power of 2 plus x third minus x2 over 2 and plus x to the power of 2/3 exponential 2 plus x third minus x squared over 2 times derivative of our power of exponential, which is 1/3 minus x.
Isn't it minus 1/3 at the beginning?
I start, yeah? Yes, thank you. Maybe we can take here x1 minus 1/3 times exponential into common. So x minus 1/3 times e2 plus x third minus x squared over 2 into common. And we will get what from the first term? 2/3 plus if we took x minus 1/3 into common, so we should divide this by x to the power of minus 1/3, means we have what? X times 1/3 minus x. X third minus x squared. Is this correct? And we can take 1/3 again into common. 1/3 times x to the power of minus 1/3. E to some power here is not important. And it is multiplied with what? Minus 3x squared plus x plus 2. Okay, now please help me with identifying critical points. What's our critical points? Minus 3x squared plus x plus 2 is 0, implies what?
From the first x to the power of minus 1 to minus 1/3, it's 0. From e to the power of the expression, it's nothing, since since it's not possible.
Right.
And from the last one, it is minus 2/3 and 1.
1 and minus 2/3. Okay. X2 is 1 and x3 is minus 1/3. Guys, once the first point that x to the power of minus 1/3 gives that x equals to 0 is a critical point, is the consequence of the definition of critical point saying that derivative doesn't exist or derivative equals to 0 is a collection of critical points. In this particular case, when x equals to 0, x to the power minus 1/3 is not defined, right? So it's a critical point. And x equals to 0 belongs to the domain of definition of our function f. So now we need to put, I forget to write the x3. What was x3? Minus 2/3?
Yes.
So minus 2/3. We have 0 and we have 1. Now we have these 4 intervals. Let's find sign of derivative on each of these intervals. So let's begin. When x is smaller than minus 2/3. Ignore exponential, it's always positive. X to the power of minus 1/3. Cubic root of x. When x is negative, that term will be negative. Minus 3x squared plus x plus 2. If we are considering very small x's, then this polynomial also will be negative. Negative times negative will be positive. From minus 2/3 to 0, here we will have positive sign. But because of x to the power minus 1/3, we have here negative. From 0 to 1, again, this polynomial minus 3x squared, etc., will be positive again, check. And x to the power minus 1/3 again is now positive, so sign is plus. And after 1, x to the power minus 1/3 is positive, but polynomial will be negative. So here we have minus sign. Let's put these arrows. One thing maybe we have forgot, let's go back to our exercise is any interval given? No. Find increasing and decreasing intervals. Let's write intervals where function is increasing. From minus infinity to minus 2/3. And from 0 to 1, f is increasing. Guys, do not use union, right? And because on the union, we don't know whether function is increasing. It's increasing on both these separate intervals from minus 2/3 to 0 and from 1 to plus infinity, function is decreasing.
Can I ask a question about the union? So, for example, if we have some middle point in between one of this, for example, between 0 and 1, we have 1/2, which is not in the definition domain. Can we write union that way or not?
It's always tricky. Like imagine in this situation, so function here is increasing and here is increasing, but in union it is not increasing because this point is greater than this one. You mean your two intervals
Yes.
have the same endpoint?
Endpoint. Yes.
In that case, function is continuous at that point or not?
At that point, it's just not defined.
Function is not defined, so we can say on union it is increasing. Imagine a situation when function is increasing like this and also increasing after this point.
But if it's, for example, continuous and this
If it is
applies to the
continuous, then
union,
everything, yeah. If it is continuous, then you can say on union as well.
if we write and, it won't be a mistake, right?
It won't be classified as the wrong answer, yes. Yes.
Thank you.
What about local minimum maximums for this exercise?
Մի հատ հարց տամ էլի։
Այո։
Իսկ եթե ասում ես strictly increasing ինտերվալները, ուրեմն մենք այս 0-ական կամ undefined կետերը, բայց որը դոմեյնում է, չենք վերցնում բանի մեջ, չէ, ինտերվալների մեջ, այսինքն բաց ինտերվալ են գրում։
Չէ, կարաս էլի փակ գրես։ Էլի կարող ենք։
Բայց ինքը այդ կետը 0-ա, ուրեմն function-ը ածանցյալը մեծ չի 0-ից, այլ մեծ կամ հավասար է օրինակի համար։ Ու ինքը strictly increasing էլ չի համարվում։
Sense. Արի sense պատկերում 0-ից 1 փակում ինքը strictly բացում increasing է, 0-ից 1 ինքը գնալով մեծանում է։ Հիմա երբ որ 1 կետում է դիտարկես։ 1 կետում ինչ է կատարվում։ Եթե ֆունկցիան continuous էր ամեն ինչ նորմալ է, 1-ում արժեքը 1-ը ավելի մեծ ալնելու, քան 1-ից փոքր կետերում։
Հա, այսինքն եթե տենց հարց լինի, փակ ինտերվալն է։
Էլի փակ ինտերվալը կարելի։ Այո։
Լավ, merci.
May I ask a question?
Go ahead, yeah.
If it says find extrema points, we should write in an answer only local extrema points or globals as well.
You should ask during exam what do we mean by just extrema point, local or global. We should precise. It should be given exactly find local or global extrema points.
Okay.
Like here, it's mentioned about only local extrema points. So here we have local maximum, local minimum, and local maximum again. Huh? Okay.
Can we do show work 3 from this test as well?
Show work 3.
Իսկ մի հատ հարց տամ էլի, իսկ եթե օրինակի համար մենք նման մի հատ բան ստանայինք, այդ ածանցալի ինչ որ բաներ ստանանք, ինտերվալներ, չստանանք էլի ուղղակի այդ գիծը եւ այդ ոնց որ որտեղ պլյուս է, որտեղ մինուս է։ Էլի այդպեսի 0 լիներ, բայց 0 կետը չլգներ դոմեյնում, բայց օրինակ համար ինքը դնել։ Մենք այդ 0-ն
փակ չենք վերցնի, դեպքում բաց կվերցնենք։ If 0 doesn't
հա,
belong
բայց
to
էլի դիտարկում ենք, չէ, որպես բան կետ,
հա,
ինչ որ հնարավոր։
առանցքի վրա նշում ենք այդ կետը, հատուկ նշում ենք այդ կետը, հա։
Լավ, մեկ էլ մի հատ էլի հարցից, եթե օրինակ համար տված է LNX-ը, որ sense մի հատ բան է։ Ֆունկցիա LNX-ով բան, ու ասում է գտեք բանը գլոբալ մինիմում մաքսիմում։ Մենք limit-ով դիտարկենք, օրինակ 0 կետը, չէ։
Հա, եթե բաց ինտերվալա պետքա լիմիտը նայենք, որպեսզի գլոբալը գտնենք։
Լավ, մեծ շա։
Okay. F of x is e to the power of 3x plus sinus 2x plus x5 plus 2x. Has exactly 0. So we should apply first IVT to prove that it has at least 0. To do that, first let's calculate F0. F0 is 1. And that's it. Okay, so it's positive. Now our task is to find a point where function is negative. Help me. At which point function could be negative?
Minus 10.
Minus 10.
Minus 10. Minus 1 also could be correct. E to the power of minus 30 plus sinus minus 20 minus 10 to the power of 5 and minus 20. Of course, this is a negative number, definitely, yeah. Sinus could be 1 maximum. Then f is continuous, implies IVT implies there exists c from minus 10 to 0 such that fc equals to 0. So we are done with this part, that there is at least one solution. Now, to prove that it's exactly 1, we have to calculate derivative of function f and prove that it is monotonic. If it is the case, then we have exactly one solution. Monotonic function may have at most 1, 0 if it is continuous. Huh? And f prime x, what is f prime x? 3 times exponential 3x plus
2 cosine x plus 5x to the power of 4 plus 2.
Okay, what we can say about the sign of this expression? So here the only tricky moment is with cosine, right? All the remaining functions are positive. So 3 exponential 3x. So let's consider the worst case scenario. Cosine is minus 1 plus 5x4 plus 2. So this is always positive. Exponential is always positive. Hence, f is increasing.
Իսկ այդ IVT-ն օգտագործելուց sense օրինակ համար մեծ թիվեր է մինուս 15 աստիճանը, մինուս 15 աստիճանը, բայց ինչ որ ավելորդ justification պետք չի, չէ՞,
Եթե ակնհայտ է, no, չէ, եթե ակնհայտ է, եթե ոնց որ տեսնենք շատ մեծ թիվ գումարած կոսինուս, չէ, դա ակնհայտ է, բայց երբ որ ունենք օրինակ փոքր թվեր ու ակնհայտ չի այդ գումարը դրական թե բացական, դա պետք է justify անենք։ Բայց տեղ ասենք 15 աստիճան հանած կոսինուս x դա միշտ դրական է, դա պետք է justify անենք։ Եթե ուզում եք կարա cosine is between 1 and minus 1. Guys, in few seconds, once again, join back using the same link. Okay, guys, let's continue. So yeah, we have discussed this already. Now let's go to the next question.
Միա դες կարող եմ հարցնել անցած վարժությունից, որ մենք հատ exactly one solution.
Aya, please. So now, question from previous exercise. If no, let's go to the next question. Midterm 2018, multiple choice number 10. Mhm. So what is given here? Derivative at 1 is 2. Function is concave up. Mhm. Which of the following will be correct? Okay.
Ներսին մի հատ հարցը կարողամ տա։
Ha, իհարկե։
For ասում եմ
So now. Just on Edgar, let's see what's going on here. F prime at 1 is 2, F is concave up. Concave up is translated into the derivative of function in the following way. So if function is concave up, what we can say about F prime?
Always increasing.
Always increasing. So F prime is increasing here. If function F prime is increasing, so let's see what we can have for the derivative. So F prime x will be greater than 2 if x is greater than 1. Okay, and it is smaller than 2 if x is smaller than 1. A says derivative at 3 is less than 2. Wrong. F prime at -1 is greater than 2. No, it's smaller because function is concave up. Yeah, so F prime is increasing. What about the remaining 3 answers here, guys? I think we can think of mean value theorem. F3 minus F1 divided by 2, mean value theorem says divided by 3 minus 1 gives F prime at C. Where C is from 1 to 3. From 1 to 3, derivative is greater than 2. So this will be greater than 2. So F3 minus F1 will be greater than 4. D or E. D says F1 minus F minus 1. F1 minus F minus 1 divided by 2. is derivative of our function from at some point C where C is smaller than 1. If it is smaller than 1, this will be smaller than 2. So D also is wrong. Let's hope E is correct. F1 minus F minus 2 divided by 3 is derivative of our function at some point which is smaller than 1. So smaller than 1 means derivative is smaller than 2. So yes, E is the correct answer. So mean value theorem gives the result here.
I have a question regarding
ahead.
concave up. We are saying that if it's concave up, the function is increasing.
No, no. We say f prime is increasing, not function. F prime is increasing.
F prime. Okay. Okay. Thanks.
Կներեք կարող եմ ես Սոնայի հարցը տամ։
Of course.
Նախորդի մեջ մենք պետք է ապացուցենք, որ strictly increasing է, թե ուղղակի increasing։
Exactly one solution, strictly increasing. Որովհետև. Imagine we have function like this. It is increasing, then constant, then continues to increase. And it has infinitely many zeros in that case. Strictly monotonic function may intersect only once with our x-axis. Strictly increasing.
Լավ, շնորհակալություն։
Okay. The next one, make multiple choice 5.
May I ask a question?
Սա նայել ենք արդեն, չէ՞։ Հա։ 17 multiple choice 3. Multiple choice 3. Okay, so we have an exercise about big and small O. And previously was a question, can we by definition like discuss small big O? Actually, for small O, we are just proving statements within definition. And definition says F is small O with respect to G if F divided by G is converging to 0. For this 3, we have to consider sinus x divided by x. When x tends to 0, sinus x over x goes to 1. When x goes to infinity, what is the limit of this expression, guys?
0.
It's 0. So we have the correct answer, B. But move forward, sinus x over x squared. When x goes to 0 times 1 over x. 1 times infinity, it goes to infinity. So if it goes to infinity, C and D we can drop. And actually cosine x over x squared as x tends to 0 will be 1 over 0, again infinity. So yes, B is the only correct answer here. Next one. Okay. The next X question is again from 2017, multiple choice number 10. Mhm. F prime at 2 is 1, and second order derivative negative. Second order derivative negative means F prime is decreasing. F prime decreasing. So if it is decreasing, at 2 it is 1. At 1 it could be, this seems to be okay. At 3 this should be fine. At 4 it can be bigger than 1. At 0 it can't be smaller than 1. And at 1 it can't be 1 because it's strictly decreasing. It remains A and B. We know that F prime is always positive, so B also can't be okay. So it remains just A correct answer. It's given that F prime is positive, so it remains only F prime at 1 equals to 2. This is the only case where a function F prime will be decreasing. Decreasing means before point 2, value of function should be less than, so bigger than 1, and after 2, smaller than 1. Decreasing. Where are we now? Multiple show work 3 from 2019. Show work 3. Okay. Exactly one solution. So we are going to follow to the same path as we did it a few minutes ago. We are going to introduce a function f of x. IVT will imply at least one solution. Monotonicity will apply up to most. F of x, exponential x minus 2. Then to apply IVT, we should mention that it is continuous function. Calculate f0, we will get -1.
I'm sorry, this one says exactly one negative and exactly one positive solutions, not just one solution.
Has exactly one positive, oh, sorry. Has exactly one positive and exactly one negative solution. Okay, f0 is -1. So we are going to apply the same technique for intervals 0 to infinity and from -infinity to 0. So we are going to do twice the same exercise. Let's see. F0 is -1. Now to show it has at least one 0. For positive x's, we should find positive number where value of function is positive. What is f2? E squared -4. E squared, of course, is greater than 4. So IVT says there exists C1, which is greater than 0, smaller than 2, such that FC1 is 0. We have at least one positive. Now, at least one negative 0. Find negative x where value of function will be positive, f -5, for example. E to the power of -5 plus 3. Of course, sum of positive numbers is positive. Again, IVT says there exists C2 positive, negative. So that FC2 is 0. So far, we have existence of one negative and one positive solutions. But now we have to prove that these solutions are unique. Okay. To do that, Let's calculate derivative of our function f prime x. It is exponential x minus 1. Exponential x minus 1. And let's discuss for positive x's. If x is greater than 0. Do you agree that exponential x minus 1 is positive if x is greater than 0?
Yes.
This means f is increasing from 0 to plus infinity. Hence, it might have only one solution from 0 to plus infinity. So we have already proven that we have at least one positive solution. Now it says unique. It says at most one, so it is unique solution for positive x's. And what about f prime when x is negative? When x is negative, x is smaller than 0. If x is smaller than 0, f prime x will be negative. If x is smaller than 0. Hence, f is decreasing from minus infinity to 0. So at most one negative solution. We have proven that we have one, so we have exactly one negative solution. So we are done.
Can we do multiple choice 7 and 10 from this test?
Հեսա մի հատ մյուսները պատասխանենք 7, 8-ը չաթում գրի էլի որ վերադառնանք։
Can I ask a question about this exercise?
Go ahead.
Do we need to include 0 in one of the intervals, or there is no need?
No need, because f0 we have calculated. f0 is not 0. f0 was 1, so no need.
Okay.
No need. But
Thank you.
everything will be correct even if 0 is included.
Mhm.
16 թվական multiple choices. 3, 5, and 10. 16 թվական. Okay. From -2 to 6 open interval, it's be the graph of f prime. This is a graph of f prime, not f, of f prime. And we should find maximum minimum points for f. From f prime, it's easy to find maximum minimum points. We should find zeros of derivative. We have 1 0 here, second 0, third 0 here. And then we should, so imagine these are our zeros. This is the first one and the next two. Sign of derivative. Look, negative, positive, negative, positive. Two local maximum points. Increasing, decreasing, increasing. So we have minimum, maximum, minimum. Two local maximum points and one local minimum. No, vice versa. One maximum, and two local minimum points. Yes. 5 local, oh, come on. 4 local maximum. No, 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 no. 3 local maximum. No. B is the only correct answer here. Okay? Three, 5, and 10. Yeah, it's about squeezing theorem for functions. X tends to 0. Sinus goes to 0, and x tends to 0. This part tends to 2. F is from 0 to 2, in between 0 and 2. Then the limit of function equals to not enough information. We don't know what is the limit. It could be anything from 0 to 2, maybe even limit doesn't exist. Okay. And 10. Ce answer? This we have already discussed. Boston Yoti, multiple choice 7. Yeah, 7 are Arlen kartınca. And alternative multiple choice number 7. So given function f, which has removable discontinuous 1, jump at 2, essential at 3. Which of the following statements will be correct? So function has removable discontinuous means limit from right and left exists, but it's different from the value of our function. If that function is multiplied with x, if we are multiplying with x, are we going to have a jump discontinuous? No, of course, because limit from side again will be equal to each other, and it will be removable discontinuous, not jump. X minus 2 times f will be continuous. So when we say it's jump discontinuous, that means limit x tends to 2 from right side of fx. Exists is some constant L1, and limit to 2 from the left side of f of x again exists and is some L2, some 2 finite numbers. And when we multiply these two numbers by x minus 2 and the x tends to 2, we are multiplying with 0, we will have a continuous function because L1 times 0 will be 0, L2 times 0 will be 0, value of our function will be 0. So B seems to be the correct answer. Why C and D are not correct? Because when we have function to be, to have essential discontinuity means at 3, either limit from right, maybe limit from left tends to infinity, or sided limits do not exist. Now, if f goes to infinity at 3, we don't know what is the rate, how fast it tends to infinity. It could be faster than x minus 3. It could be slower than x minus 3. So we can say for sure x minus 3 times, so 0 times infinity will be 0, or 0 times infinity will be infinity. We don't know. So both we should eliminate. In general, both could happen. X times fx plus 2 has jump discontinuity at 0. No, we just said it's very similar to B. Here, x fx plus 2 at 0, it is the same as x minus 2 fx at 2. It is continuous, not discontinuous. So it remains just B to be our unique correct answer. Questions? Forward. Multiple choice for 2022. Mhm. So we should find true statement. The first statement is not true because we don't know whether function f is continuous or not. Continuity is not given, so we can't apply IVT. We can't say B also is true since f times g could be not continuous. So drop B as well. F times g could be not continuous, so limit exists is okay. It could be different from f6g6. It could be removable discontinuity. Module f continuous, then f is continuous. Not necessarily. If we have some function like this, 1 minus 1, module of this function will be always constant. It is continuous, but function f itself is not continuous. The inverse is correct. Statement D actually is the correct answer because this is straightforward application of IVT. At -1, 4, at -3, at 1, -3, at some point it's pi. Yes, pi is 3.14. So at some point, value of function will be pi. Composite f with composition with f, if f is discontinuous, composition could be constant. Just imagine our function is defined something like this. It's 1 or 2, depending x is positive or not. Then f composition with f will be always fx is 1 or 2. So f1 and f2 is f1 of f2 is always 2. So it is constant. Constant function is continuous. Hence, we have IVT here, the only correct answer. Seven, 8, 10. That's not negative. Seven, we did it. 8.
Իսկ մի հատ հարցն էլի,
Ահա։
իսկ կարող ասենք, որ 1 բաժնած x-ը discontinuous-ը 0 կետում, ինչքան է դոմեյնի մեջ չի մտնում 0 կետը, բայց աճից ու ծախից տարբեր լիմիտներ է։
Չեն կարող ասել։ F1 over x is continuous function, moreover. But if we say f of x is defined as 1 over x, if x is not 0, and I don't know, 0 if x equals to 0, we extend function 1 over x, and we define it at 0, then yes, f function is discontinuous at 0, but 1 over x is continuous.
No, that's
F has removable discontinuity 1, G has jump discontinuity. Yes, F plus G has removable chair, has jump. Yes. 7, 8, and 10. Once a side lighting chair. Side lighting. Summative multiple choice 8 and 10. Summative. Okay, 8. Given function 2 times differentiable. And we have table. Only this table is provided. What we can say about local extremums of function f. Of course, there's not a lot of like given here, but we can apply second derivative test. What says second derivative test? Second derivative test says first find critical points. F prime x0 equals to 0, some critical point. And then to classify that critical point, we should have look at second order derivative. Second order derivative positive point is a minimum point. Second order derivative negative, it's a maximum point. So 7, A says 7 is a local maximum. S7, local maximum. It's a critical point, yes. Second order derivative negative, yes. It's a maximum, yes. But 0 cannot be local maximum point. Cannot be checked. Second derivative test says if second order derivative is 0, then our test is inconclusive. It doesn't say anything about whether that point could be maximum or is not maximum. It says, sorry, bro, no information. Go find another way to classify this. So A is wrong just because of this claim, not be a local maximum. But 0 cannot be a local maximum. Is wrong. Can be a local maximum. 4 is local maximum, and 1 is local minimum. 4, look here, 4 is a local maximum. Testing. 4 is local maximum. No, derivative is 2. Derivative is not 0. It can't be maximum point. B is wrong as well. C, 0 is local minimum. No, we don't know what is 0. It could be local maximum or not. 1 is local minimum, testing. Derivative 0, okay. Second order derivative positive, so it's minimum, correct. 7 is local maximum, yes. It's local maximum because it's a critical point and negative second order derivative, so D. Both 4 and 7 are local maximum points. No, 4 is not a maximum point. It's not a minimum because derivative is not 0. It is not even critical point. So D is the only correct answer. Okay. 8 and 10. Find derivative of inverse function of this. Okay. At which point at logarithm 14 plus 2. Okay. The formula for the derivative of inverse function is g minus 1 prime at our y0, which is logarithm 14 plus 2, is 1 over g prime at x0. What is x0? Could you find x for which this number is ln 14 plus 2?
2.
Yes, 2. X is 2. So we should calculate derivative of g at 2 and have 1 divided by that number. Okay, what is g prime? Take derivative of g. 1 divided. What is derivative of g? So 1 over 2x squared plus 3x. Uçen rule asma var 4x plus 3 and plus 1. So if we plug instead of x in chain 2, we will get 1 divided by 4x plus 3 starts with 11 divided by 8 plus 6, 14 plus 1. Bringing common factor, we have the correct answer here.
How can we prove that the function is invertible?
In general, invertible from whole domain of definition. If, for example, we can calculate derivative and show that derivative is always positive or negative. But in this case, we are interested only whether function is invertible as x is 2 or around 2. Around 2, it is invertible since derivative around 2 is positive. If f prime at x0 is not 0 and f prime is continuous, around x0, in some neighborhood of x0, it will be invertible.
Okay.
Huh? Uyhasank. Multiple choice 10. Last minute tabakan, multiple choice 8. Okay. So given graph of f, we should understand what is f prime. First thing that we will do, we will eliminate d because of this part. Here, derivative is positive. If derivative is positive, function should be increasing, but our function is not increasing here. So d we can drop. A, B, and C. Their big difference is here. For example, if we focus on graph B, near point B, derivative is negative. Function should be decreasing, but no, function here is not decreasing. It is increasing. Derivative should be positive. Drop this one, and it remains A or C. Flip a coin, or look here. After point B, graph C says function should be decreasing because derivative become negative.
It's A.
It's
so it remains only A to be correct, right? Because function before and after point B is increasing, so derivative should be positive. Oh, so here A is the correct answer. Do we have none of the above? Lovely. Machasik, why none of the above is not the correct answer? Maybe something is wrong with A as well. Come back in 1 minute, guys. A is kaçer, işte. Okay, 21 shall work 3. So we have to calculate limit. Okay, let's do the following. Let's do not, from the beginning, do L'Hopital. Why? Because, look here, we can split it into the following two parts. Sinus 5x plus sinus 3x minus 8x divided by x cubed times x over sinus 2x. Look, we have divided by and multiplied with x. This part converges to 1 over 2, right? You can multiply and divide by 2 and apply useful limit. And so we can just focus on the limit of this part. Why? Because now the numerator here is better than x squared times sinus 2x, and applying L'Hopital will be easier. So let's do the calculation. Actually, it is 0 over 0. It's straightforward. So we can apply L'Hopital. Let's do it. So here we have 0 over 0 form. So we can do L'Hopital, and after applying first time L'Hopital, we will get 5 cosine 5x plus 3 sinus cosine 3x minus h divided by 3x squared. It is still 0 over 0. So let's do again L'Hopital. X tends to 0. Now we'll get minus 25 sinus 5x minus 9 sinus 3x divided by 6x. Again, 0 over 0. Let's give up, because every time we are getting 0 over 0. Come. Another L'Hopital or useful limit. What we can say about sinus 5x over x? It tends to 5. Sinus 3x over x tends to 3. So limit here will be minus 25 times 5 over 6 and minus 9 times 3 over 6. And leave it like this or simplify, up to you.
Ինչ կարա ամենասկզբից էլ վերևում, որ ստացել էինք երկու մասի առանձնացրել էինք useful limit-ով անեինք։
Indeterminate form ստացվեր միշտ. If you sinus 5x over x cubed converge to infinity, to infinity plus infinity minus infinity. We are going to have infinity plus infinity minus infinity if we just think of only useful limit. So we'll get indeterminate form. Թվական, multiple choice 4, 5, and 10. Sա օրենք։ թվական 4, multiple choice number 4. Էսա չենք կարա։ F, so we should find true statement. Double derivative positive means function is concave up, and here we have a lot of expressions similar to the definition of concavity. Concave up means Okay. The definition. Why it is so big? So concavity definition says f alpha x plus 1 minus alpha y should be greater or equal than alpha fx plus 1 minus alpha f. Am I right? Concave, I wrote what? Concave up or concave down? Concave up, value should be smaller, not greater. Let me fix it. Value function smaller than this. What says A? I think 7 now. Why it should be with 7, correct? Not sure. Fx could be negative. Just multiplying with 7, we can't make things even worse. What? Bin alpha is 1/3. It seems B is correct. It is just the same definition. Instead of alpha, we have 1/3. For C, we have against this 7 coming, not clear why. For D, alpha is 1/2, so we have to get here divided by 2. That 2 is missing. And E, greater, smaller. It should be smaller. So the correct answer is this B. Okay. Uh-huh. 4, 5, and 10. 5. F continuous differentiable. So we can apply mean value theorem. We can apply all theorems. We should find false statement, guys, here. To do it, the first one is mean value theorem. So it is correct. F prime C equals to 0. It seems to be a row theorem. But for row theorem, we need to have FA equals to FB. That condition is not given. No, differentiable at AB and attains equal values at A and B. So FC equals to 0. IVT, but IVT we can't apply. We don't know whether function has different signs or not. So let's just so far think that C is our false statement because IVT we can't apply. F is bounded on AB. Yes, continuous function on closed bounded interval is always bounded and has maximum according to extreme value theorem. EVT. So here seems that, we have found the correct answer. Okay. And 10. Ha, sanayilən qarşıya. Okay. Some mektubakan show work one. Okay, we should find equation of tangent line. Let's do it. The trick here is that given implicit function. So, but again, to get equation of tangent line, we have to first calculate y at 0, and we have to calculate y prime at 0. After that, we can easily get the equation of tangent line. What is y0? To get this, we should plug instead of x 0. If x is 0, we'll get y cubed 0 plus 0 times whatever plus exponential to the power of 0 plus 1 equals to 9. Hence, y at 0 is 2. To find derivative of y, let's take derivative of whole equation. 3 times y squared times y prime plus 2x arctangent plus x squared over 1 plus x squared plus exy times y plus x y prime equals to 0. And if we plug into this equation x equals to 0, look, the first term will be 12y prime at 0 plus 0 plus 0 plus e to the power of 0, 1 times y0, 2 equals to 0. So y prime at 0 is minus 1 over 6. And finally, the equation of the tangent line is y equals to minus 1 over 6 times x plus 2. Seems we are done. Տասնինը թվական 7 7-ն այցինք Տասը. Okay. It's about again mean value theorem. So f prime at 2 is 3. F strictly concave up. Strictly concave up means f prime of x is strictly increasing.
Բայց չի ասում strictly concave down.
Down. Ասում է, ես հալ եմ կարդում. Strictly decreasing. This is a sign that I'm getting a bit tired. Okay, f prime x strictly decreasing. Strictly decreasing, we should find false. F prime 2 is 3, f prime 3 is less than 3. Of course, it is true, so it can be false. Yeah? F prime 1 bigger than 3, decreasing function, yes, so it can be false. And C, D, E, let's discuss collectively. It's about mean value theorem. for example, C, fx minus f2, take f2 to the left-hand side, divide this stuff by x minus 2, since x is greater than 2, and the claim is it is going to be greater than 3. Let's check. So here we have f prime at C, where C is bigger than 2. So if C is bigger than 2, f prime C should be decreasing, means smaller than 3.
Can I say something?
Of course.
So in C, isn't it the equation of the tangent line?
Okay.
Of our function. So
it is.
we know that the tangent line should be, if it concave down, should be greater than our fx. So isn't it like easier to do like that way?
Correct. It is easier if we think of concave up is a function where tangent line is smaller than function itself. It's concave down. So sorry. Concave down. Function smaller than tangent line. Yes. So C is wrong. But why I wanted to prove it by mean value theorem, because for D and E, mean value theorem is needed to be applied. With N with T, we can discuss D and E. But yeah, you are right. We can easily find that C is wrong by tangent line being greater than function itself. Okay. So what about D and E? F2 minus F minus 1. Let's divide whole stuff by 3. Is it going to be smaller than F minus 1 minus F minus 4 divided by 3? So here we have derivative at C1, derivative at C2. C2 is greater than minus 1, C1 is smaller, so C2 is bigger than C1. Derivative decreasing, yes. The same way with D, as D negative. The same with E. E also is true. If you divide by 2, that's x, divide by 2, divide by 2. Derivative from 0 to 2 is greater than derivative from 2 to 4. Yes, of course, decreasing. If I suggest to take a break and continue our discussion on Monday in Shkasek. Լրություն համաձայնության նշանը։ Եկեք սենց անենք։ If you have some questions that we didn't discuss today and you spend a lot of time on these questions, let me know. Just drop me an email. We can organize some individual meeting either today evening or tomorrow during the day and discuss your questions. Otherwise, we are going to repeat maybe. So I think we have discussed almost all types of exercises. So I will let you to enjoy this Thanksgiving evening. And if you have questions, let me know. Drop me an email. Let's stop now.
Merci շատ, ստեցին ձեզ։
Ստեցություն։
Merci շատ, հաջողություն։
Շատ հարցն է։
Այո։
Այս որ ձայնագրել եք, ցելո եք, որ մենք նայենք։ Այսինքն որտե՞ղ։
YouTube գցեմ։ Նախորդ անգամ էլ չէ, գցե YouTube, չգիտեմ, այդ լինքը ունեք, եթե ունեք, այդ նույն channel-ում է լինելու։
Իսկ մոտավորապես երբ հասանելի կլինի արդեն։
Այսա շուտով հենց հիմա կգցեմ YouTube, մի կես ժամից, մի ժամից արդեն հասանելի կլինի։ Մոդուլում կդնեմ լինքը, եթե նախորդի չեմ հիշում, նախորդը դրել էի մոդուլում լինքը,
Հա դրել էիք։
այդ նույն channel-ում կավելանա վիդեոն։
Merci շատ։
Okay guys, thank you.
Հաջող